Good afternoon, everyone. Welcome to Tormont's Let's Talk Energy session on transforming mobile power applications using diesel and BESS hybrid systems. Good afternoon, everyone. My name is Sharanjit Singh, and I'll be the moderator for today. I'm the Tormont Power Systems Business Strategy and Rental Operations Manager, and we have an exciting team of well-experienced panelists today. First of all, I'd like to introduce to you Oscar Medina. Oscar Medina is Tormont's Rental Manager for Ontario West and Ontario and the West. Oscar, would like to say something to our audience?
Yeah, hi. My name is Oscar, and I've been with Tormont for almost 9 years, and has been working in different divisions like power system and heavy equipment. Even back in my days back home, I worked for the mining division as well.
Thank you very much, Oscar. We look forward to your discussions today. Next we have is Travis Wenio. Travis is the Senior R&D Manager at Enacorp Corporation. Enacorp is the manufacturer of battery energy storage solutions that we're highlighting today. Travis would like to say a few words to our audience.
Sure. Thanks for having me on this webinar. My experience really comes from hybrid systems and electrification in automotive, and that's really transformed over into the industrial space here with hybrid energy systems at ANA. So really excited about the product we're bringing forth, and happy to see the intake and how well Tormont's figuring out how to put it to use.
Thank you, Travis. Last but not the least, we have Johnny Medeiros. Johnny Medeiros is Tormont's rental manager for the Quebec and the Maritimes. Johnny?
Yeah, good afternoon, everyone. Very happy to be here as well. So I've been with the dealer for about almost 15 years now, always in the rental, always in the heavy rents energy side of the business. Very good knowledge of the Quebec province, especially. So looking forward in having this new product in our product line.
Thank you very much, gentlemen. So moving along, before we get into the meat of today's discussion, just like to share the disclaimer. This presentation and the information contained herein are provided without a prejudice basis and does not constitute, nor should it be construed to constitute legal advice or a guarantee, offer representation or warranty on behalf of Tormont. The panel members will be offering suggestions to several possible customer scenarios. The answers given by the panel members should not be used as a guide. Please be aware this webinar is being recorded. If you do not wish to be recorded, you may leave the session at any one time. Electrical safety is paramount at Tormont. We take great lengths to ensure that our staff and our customers are safe at all times. So, since the topic is about electrical safety, BESS, and generator sets, what's more important is then understanding why grounding is essential for BESS. Proper safety grounding ensures that fault currents that are safely discharged into the earth, protecting the personnel and the equipment from electric shock or fire hazards. This is also to make sure that in case of a thermal runaway, reduce downtime, avoid component failures, and injury to human life. There's also a regulatory compliance requiring that grounding meets certain standards such as NAC, IEC, and in Canada, the Electrical Safety Code. Please ensure that the generator is grounded to specifications as outlined in the generator specifications and user manual. Failure to properly ground generators may result in damage to the e-bus and possess safety risk to the users. In our rental equipment, generally we have a sticker that is close to where the circuit breaker is located, in which it highlights that all electrical installations have to be inspected by the Electrical Safety Authority. And it has to meet the Electrical Safety Code. And please ensure that the generator is locked when it is unattended. So this to ensure that anyone just before energizing a unit has been reminded that it has to meet the regulations, and also be inspected by the Electrical Safety Authority. Questions? Any questions that you come across during the presentation, please feel free to add it to the chat or email directly to me. My email address is ssingh@tormont.com. So today's presentation is based on some of the questions that we have received during our work, and it will be a series of questions that will be geared towards our panelists. So the first question goes to Oscar. What are the rental products and services that does Tormont Power Systems offer?
So as you know, Tormont is a publicly traded company, and it's a cat dealer for the eastern of Canada. And we have around 48 branches across 7 provinces and territories, and around like 6,000 employees. On the power system division, we have different or multiple equipment, as you know, like generators, distro panel, ATSs, fuel tanks. We also have like a HVAC product, like chillers, AC heaters, and our new and that's why we are here today, is to present the new equipment, which is the battery storage system or the hybrid system that we have. Along with all these, we have a group of salespeople that goes across Canada, and they can present even contingency plan for your work or jobs.
Thank you very much, Oscar. Just to emphasize that Tormont Power Systems does contingency planning to ensure that in case of an outage, equipment, the site is already been surveyed up, equipment is verified based on the requirements, where the equipment will be located, how it be wired up, etc., so that when the need comes, there is minimum disruption and downtime to ensure that it meets the requirements of the facility. Thank you, Oscar. Going forward, getting into the meat and potatoes of today's discussions, what is a diesel BESS hybrid power systems? Travis, could you look at that?
Yeah, so let's get into a couple of different architectures for what the types of hybrid and BESS systems we work with. Traditionally, everybody knows the standard diesel generator. They would always roll that generator onto site that needed temporary power, add diesel, and get power. Essentially, that's the way it's always been done for many, many years. More recently, they've found there's a lot of advantages of adding a battery to this generator, and we'll get into the details of what that does in future slides. But really, there's been starting to bring in batteries into systems just for a few reasons. This system here specifically shown is where you bring in 2 different assets to the job site. You roll your standard generator in, and then you would roll in a battery system. And with this system, I call this an AC coupled system. So the generator can power the load or the battery can power the load. So the battery can, if the generator is running in a light load condition, the battery can run the load and then call the generator to bring in the gen as needed. So this is called an AC coupled system. It works pretty well, but there's some transitional concerns where you're switching the loads between the battery and the generator. So this is what I call a DC coupled system. This is something that we put together, that front system. And essentially, in this system, because it's DC coupled, the generator turns into a battery charger, and the battery is what powers the load directly. So there's never a transition between the generator turning on and off and the AC output signal having to have that transition between the two. So this is, like I said, this is called a DC coupled system. We'll get into a few of the advantages and maybe some disadvantages around the DC coupled system and how that functions in future slides as well.
So Travis, just to reinforce the point here, is that we have the diesel generator set and the EBOS mounted on a trailer a roadworthy trailer that's certified and can be moved around and made mobile for any rental application.
Yeah, exactly. So this one is you roll that same, roll a piece of equipment on site, and it works just like a regular generator, but it has all the advantages of having the hybrid system there as well. So you don't have to necessarily bring in two different pieces of equipment. Roll one piece of equipment on site, add diesel, and it gives you power in the same way as standard gen would.
Thanks, Travis. So, what are some of the objectives of the hybrid system, Travis?
Yeah, one of the first objectives is let's prevent that generator from wet stacking. We look at, A&A is a distributor of generators in the rental industry, and we have, we've pulled a lot of our generators for average loads. In the rental industry, the average loads across, we've pulled probably 4,000 units. The average loads on those generators are about 10%, which is very low considering, the capacity of those generators. But when you run a generator at 10% load for an extended period of time, anybody that's had a, tier 4 emissions or a later emissions engine knows that if you run that continuously at low loads, you are going to wet stack. You're going to plug that emission system up. And to prevent that or prevent wet stacking, you have to go out and load bank the generator to make sure you keep that emission system cleared out. So with the hybrid system, that's one of the first objectives is let's prevent that engine from wet stacking, because that can be a significant cause significant damage to the engine if that emission system plugs up. So when we look at the hybrid objective, we say when we turn that diesel engine on, we want it to be running for about 30 minutes at least 60% load to make sure that it gets good and hot, the catalyst heats up on the exhaust, and that emission system will stay nice and clean. The second objective is let's try to maximize that generator efficiency. If you look at the fuel burn curve of a generator, like on the right here, it's at 1800 RPM, which is 60 hertz, what we use here. If you're running that engine at 10% load, you're getting, I like to call it the fuel mileage of power generation, where you're talking in terms of output energy delivered per gallon of diesel that you put into the equipment. So at 10% load, that metric on a standard generator is about 4.4 kilowatt hours of energy per gallon of diesel that goes into that gen. At 90% load, that generator is much more efficient. You're getting about 4 times the efficiency at 14 kilowatt hours per gallon at 90% load. So now what we're trying to do is maintain that generator efficiency even on a light load on the output scenario to make sure we're getting the max amount of energy per gallon of diesel we put into that generator. The other really interesting point is we like to utilize the existing service and fueling network. If you're used to rolling a diesel truck on site, every day or every few days, depending on the job, to fuel up other equipment, let's use that same fueling network. I don't necessarily want to have to tow a battery on site, run it, and then tow it back off. That's not using the existing network. You'd have to build a new infrastructure and fueling network for that. So let's use the existing fueling network that's already on site, a diesel truck, and then service as well, right? You have diesel maintenance techs that go out and do oil changes and stuff. Let's try to use that infrastructure as much as possible when we build a hybrid system. The other really important one is operational conditions, especially, the winter in northern Canada, in the US as well. We see a lot of cold weather. So we need to make sure that a hybrid system can handle the same conditions as you would with a standard generator. If you would roll a standard generator up into, Fort McMurray, -50 C, the objective is let's make the hybrid system be able to do the same thing. So you don't have to really sit there and think, is this hybrid system going to work in this cold weather environment or hot weather? No, if you think a generator could run there, think that a hybrid system could run in the same space. When we design systems, that's how we want to look at it. And then last as long as a generator. So we don't necessarily want to we want to make sure that the hybrid system or the battery system is going to last years and years, especially when we talk about the generator runtime reduction, like we will in some of the case studies. We want to consider how many less hours there are on that generator. We want to make sure those assets have a similar lifetime at least, so we don't have to replace the batteries every few years and that generator doesn't have a lot of hours. So there's lifetime considerations. And then starting capability, you just want to make sure that if you could start something with a 70 kVA generator, you could start the same piece of gear with a 70 kVA hybrid. So.
Thanks very much, Travis. So moving along, what are the capabilities of the hybrid system, including rating, ambient capabilities, life, etc.? We're pleased to highlight the capabilities of the new units that we have in our rental fleet. And Oscar, perhaps you could share some details here.
Yeah, so currently we have two of these products in our fleet. The first one is the battery, the 70, that is paired with a XQ35 kVA CAT generator. This unit, can do 208, 480, and through a transformer, if you see it on the picture, can do 600 volts at the same time. This unit is 25 kilowatt per hour. And the charge time is 45 minutes. The life of the battery is around 80 to 90,000 cycles. And the good thing about both units that we're going to present today is because they can manage the cold temperature. They come with a cold weather package, and the range could be around the minus 46 degrees. That one's the first one. The second one that we have is the battery 125. Which is paired with a XQ60 kVA CAT diesel generator. That unit can provide 50 kilowatt per hour, and it's around the same cycles as the other one, around 80 to 90 cycles. And the range of temperature is similar to this one. Both units are equipped with a telematics, so with some kind of a GPS system that you can track down and see alarms and different stuff. And those are the two products that we own right now.
Thanks, Oscar. So these units are geared for our Arctic conditions, long longevity for the batteries, and reliability of the diesel generator set.
Exactly.
So what are the implications of fuel system maintenance, noise, and exhaust emissions? Johnny, could you share some details?
Yeah, absolutely. So on to start with, obviously, by using the hybrid system, we'll be running the generator a lot less. So we'll eliminate noise, reduce fuel costs. By doing so, we'll reduce CO2 emissions, reduce air pollution. By running the generator with less, obviously, you'll have lower maintenance and services to do on the generator itself, and it will increase the asset lifetime.
Thank you very much. So it's a win-win situation all the time, including reducing noise, lowering emissions, lower maintenance cost on the unit, lower fuel cost, reducing pollution, and increasing asset life.
Correct.
So what are the typical applications for diesel BESS hybrid systems, Johnny?
So hybrids are ideal power generation solutions for a variety of industries and applications. For example, in the construction industry, especially in remote areas where grid access is limited, it can power tools, lighting, temporary offices. We're seeing this also being used in manufacturing by storing energy during the off-peak hours. We'll see this obviously in the film industry or events where where the batteries the BESS offers quiet or less noise. It could be used for the sound equipment, production trailers, even for some lighting. And it's especially valuable where noise and emissions from the generators are problematic, right? We'll see this also being used in utilities for grid stabilization. We'll see this also being used in commercial buildings for backup power to ensure business continuity during outages, power outages, sorry. We'll see this possibly also being used in municipalities or for emergency services and critical infrastructures. Sorry. We'll see this also being a possible uses for hospitals, where it can provide reliable standby power for critical systems like life support. And finally, we'll probably see this also in the disaster relief, where it can deliver rapid deployment, power for shelters, medical stations, and communication hubs.
Thank you very much, Johnny. I'm sure we'll have later on during the presentation, we'll share some examples of how these particular packages were used in some of the applications.
Correct.
So now that we have looked at what our BESS diesel jet hybrid system is, what is its capabilities, what can be used for, the next thing is obviously one can get a unit from Toromont Rental Group, and now is how do we set this up so that it leads to a good operation for the system. So transportation is being number one. I think first thing, it needs to be transported. So Travis, could you share some details about transportation requirements? Yeah.
So there's requirements around UN 38.3, which is a battery specification for transportation. So it's making sure you have the proper documentation and test results for proving that we can meet UN 38.3. There's also some other, the MSDS can be required. And then battery packaging, obviously, since this is a full system, all of the packaging is taken care of by the manufacturer to make sure that it's, the batteries are packaged in a safe method. And essentially with the battery chemistry we have on here, we're not worried about the thermal runaway because it's a lithium titanate oxide battery. Essentially what that does is that means we have a thermally safe battery at the cell level, so there's no system level protections required for thermal runaway. So that can give you peace of mind as you're towing these units around and transporting them on site.
So what is the state of charge on these batteries prior to shipping?
Yeah, so with these batteries, you can move them at any state of charge. Obviously, since you have a generator on site as well, or on the same trailer, you can move them at a lower state of charge, but based on the test results for these batteries, there's no requirement for the state of charge that you have to ship them at. There are some where they recommend shipping them, below 50%, 30% state of charge to reduce thermal runaway risk. Since this is at a thermally safe at a cell level, that requirement doesn't apply to the LTO chemistry that we've got on this unit here. That's part of the consideration for transportation.
Thanks very much, Travis. So charging of batteries, obviously there's always a question that comes through. How fast, how slow can it be charged? Travis, can you share some details as to how this is determined? Oscar already mentioned for one of the batteries that it can charge within 45 minutes. So if you could share some details on what the C rate is and how is it determines the rate of charging for the batteries.
Yeah, definitely. So when we talk about battery C rate, essentially the easiest thing to do is look at an application. So if you have a 100 kilowatt kilowatt hour battery pack and you charge it at 100 kilowatts, that basically means that you will charge that battery to full in 1 hour. So we call that a 1C charge rate. If you were to charge that 100 kilowatt hour battery pack at 400 kilowatts, that would be a 4C charge rate. So this battery system here, the 70 kVA, has a 25 kilowatt hour battery on it. So essentially, if you're discharging that, or if you're charging that at about 28 kW, which is what that XQ35 does, it's about 45 minutes to a little bit over 45 minutes to charge that battery pack to full. So that's essentially that's one of the unique benefits of this hybrid system is because the generator is always there to provide the continuous output capability, the battery is just there, just big enough to make sure that that generator is running at its most efficient point. So that's a little bit talking around the charge rate. With the LTO chemistry, we can charge and discharge it very rapidly. That's one of the points that Oscar had mentioned. Without any, because of the internal resistance of the battery is low, it means that it's going to be a much more efficient package, both size-wise on the trailer and also, efficiency-wise because of the battery chemistry.
Thank you, Travis, for clarifying the charge rate of the battery. So in this particular case, it's a pretty robust battery that meets low ambient conditions, and also charging is very fast on this.
Yeah. Yep.
Excellent. So now it comes, we have charged up the battery and we're ready to use. How is the discharging function controlled, and what are the implications on the lifespan and performance of the unit?
Yeah, so this system here, Oscar also mentioned the battery cycle life ability of this battery. That the LTO battery chemistry, essentially, we get up to around 80,000 cycles on the battery, which means we're kind of building this like maybe a Ford Power Boost pickup, right? The battery size is really small. It's charging and discharging as needed, but it's maintaining the overall efficiency or making the overall system efficiency higher. When you talk about power capacity, essentially this unit here, we talk about it being a 70 kVA output capability. That basically means the output, you can put out 70 kVA as long as there's capacity left in that battery. Once the battery discharges all the way, now the only where the battery isn't generating energy, it's just a storage tank. So the generator is always there to bring in that continuous power and to recharge the battery. And the battery itself is kind of like that short-term storage tank where you can run 70 kVA on that system until the battery discharges, and then at that point you're left with whatever you've got left on the battery. On the generator. So essentially, it's the 70 kVA is designed for peak loads. You're running it hard for motor starting, pump starting, and then the generator is there to kind of refill the battery at a more slow rate.
Thanks, Travis.
Mm-hmm.
So one of the things that we talked about is safety and protection. Safety is always paramount. And could you, Travis, speak about some of the safety and protective devices that are on the BESS to make sure there isn't a thermal runaway, or in case of an event, there is no destruction?
Yeah. So we talked a little bit about the thermal runaway and protection at the cell level. So making sure that battery is just thermally safe at the lowest level, so you don't have to, have fire protection and different extinguishing methods. We designed it based on that cell level chemistry being inherently safe. from thermal runaway. So it has the most protection at the cell level against thermal runaway. The other one that's really interesting is because this is a DC coupled system, like we talked about before, the load is only coming off of the battery. So the generator then just charges the battery through the DC bus inside of the system. What this really means is the inverter is what's powering the load. When the load is only powered off of the inverter, now that inverter can control what we call, I'm sure everybody's familiar with the NFPA 70E arc flash rating. And with standard diesel generators, they have a fairly high arc flash protection boundary where you exceed the 1.2 cal per centimeter. I'll get really into the weeds here with that incident energy of a standard generator. But because we have an inverter that drives the output, the inverter detects it's basically a millisecond level, detects a short in the output system. So what that allows that inverter to do is detect that output and reduce the output energy so you don't have a large arc flash event downstream of this system because that inverter is controlling the entire load. So essentially what happens is, in this case, that inverter is going to really reduce the arc flash protection boundary of anything downstream of this hybrid system output. For example, a normal arc flash protection boundary on a standard generator might be, maybe it's probably like 90 centimeters or close. It's actually closer to. I think it's a meter plus for arc flash protection on a standard generator. When we did the arc flash protection calculation on this system with the inverter driving the output, that arc flash protection boundary was like 71 millimeters, which means that it's almost on this 70 kVA system, the arc flash rating is significantly, or the arc flash incident energy is significantly reduced. So that's a really cool feature that I think is valuable for anybody working downstream of a hybrid system like this.
Thank you very much, Travis. So protective devices are there to protect the equipment in case of any incident disruptions that might be, or surges in the power.
Yeah, and anybody downstream, anybody working on the equipment as well.
Excellent. So one of the things we spoke about was the starting load capabilities, where battery energy storage systems are used together with generator sets to start large systems such as pumps and motors, so in this particular case, using battery energy storage solutions, generator sets can be optimized. Travis, could you share some of your experience in this field?
Yeah, really, when we went to size this system, we said, first let's optimize a diesel generator. We talked about those objectives earlier on. The other thing we didn't want to do is we didn't want customers to have to really think through or change the mindset for how they sized a system when it comes to the hybrid system. So if they said, okay, I know I could start a certain piece of equipment with a standard 70 kVA generator, the intention was to, when you have a hybrid system, you can start that same piece of equipment with the similar rating on that system. So if you can start something with a 70 kVA gen, we designed it so you could start that same gear with the 70 kVA hybrid system here. And really what that allowed us to do, a normal generator, the rule of thumb is, you're designed to handle up to 3 times the generator nameplate for like motor starting. So it's 100 milliseconds, very short period of time. So a 70 kVA gen might be able to start, 210 kVA load, or about 150 kW load for that 100 milliseconds just to get past the lock rotor amps. And so we did the same thing. A lot of battery systems, they might only rate it. Peak is 1.1 or 10% more than the continuous rating. We took that to the next level to match it to a generator. So we really oversized our inverters, the output. So then you wouldn't have to think through, okay, if I could start this thing with a generator, what battery size do I use? No, you just use the same rating battery size and it'll start the same piece of gear.
Thank you very much, Travis. So now we have looked at the advantages of the battery energy storage systems. What are some of the typical applications, transportation, and safety devices? This is really the exciting stuff here now, is where can it be used? And we've got quite a few examples here that we'll share with you on how and where the battery energy storage systems have been used. So the first one is some office trailers. Johnny, could you share some details on this, please?
Yeah, absolutely. So this is a case study that occurred last summer. So the request was to power 2 office trailers in downtown Toronto during a construction project. The office trailer consists themselves of about 6 to 8 office stations with computers and some AC units. So the hybrid system proposed was a 30 kilowatt-hour battery coupled with a 45 kVA mobile generator that you could see on the picture. The generator was actually run with no load during the evening and at night when the employees were leaving the office, right? So it made it the perfect scenario. So barely no load during the night and evening, but essentially some load during the day. So the wet stacking situation was something we wanted to prevent.
So this is an application where we had high load during the day period and very light load during at night. So Johnny is going to share some details on this particular project. So this is project specific, like I said, which may or may not be applied to any other project, but this is specific for this project. And here's some details from Johnny.
Yeah, absolutely. So from a customer's standpoint, right, on the left-hand side, we want to compare if we'd be using only the generator, right? Typical, power 30 kilowatt generator powering up those 2 office trailers. And on the right-hand side is what we proposed to the customer, which was a generator matched up with a battery, right? So on the cost financial, what's the impact for the customer? This is what we want to analyze. So if you'd be running the generator on the left-hand side, you could see triple shift because it's going to be running even with barely no load during at night, but it'd be running 24 on 24. So it's 24 hours a day running. And so it represents 720 hours of running time during that month. So our rental rate for that 30 kilowatt per hour running triple shift, we put it on there compared to you'd be running the generator only a single shift. So the rental rate for that generator would be less. So right off the bat, the customer would save about 26% for his rental rate. That translates also on the maintenance fees, right? So if you'd be running the generator 720 hours during the month versus only 180 hours during the month, you'd have a 67% savings on maintenance and on maintenance fee. We also, like any other company that does rental, have the insurance. So it's 14% of the rental rate. So obviously the rental rate being lower because the generator is running less, you'd be saving as well 26% on there. And the big impact is the fuel consumption, right? Because the generator is only going to be running 180 hours, and the battery picks up the load during the balance of the time. There's economies there, assuming that the customer paid $2 a liter, it'd be about 75% savings. Now, on the other hand, though, on the right-hand side, you'll see there's add-ons to this. Because you're adding another piece of equipment, there's going to be a rental rate to this. So we added there a price. There's going to be insurance to pay for that battery as well, and we added the $3 per hour for the maintenance fees on the battery as well. That being said, if we add up all of the costs to it, the customer had a monthly saving of 22%, which is about $3,000 a month of savings using 2 pieces of equipment versus the generator itself. And on top of it all, if we're looking for on the emission side of things, there's a 77% that we calculated emissions, CO2 emissions difference from running the generator only a single shift.
Thank you very much, Johnny. So in this particular case, using the BESS, the generator set was running at its optimum efficiency, high loads, and not really running at lighter loads on compared to the case on the left-hand side. Also want to clarify that the fact is that the CO2 emissions is a calculated number. It's not a measured number for that case, like Johnny?
Correct.
Thank you very much. So the next application is a concert. This is a concert that Oscar will share details about.
So yeah, this was a music festival that happened in north of Ontario. It calls Tall Pines, where the customer requests having some kind of distro panels in place. If you see the picture, all the equipment is behind the stage. And we propose to offer one of our battery storage system, just because noise and saving fuel plus the fumes on site. And we provide this generator. As you see, it was really quiet. The customer was really happy with the performance of the unit.
Thank you very much, Oscar. So the first application was fuel reduction and emissions reduction. In this particular case, noise was a criteria that helped with the application, and obviously emissions that might be coming from the exhaust for people's comfort. Thank you. Yep. Travis, you did a white paper on some hybrid for a construction site.
Yeah, this was actually done by a customer of ours. It's a case study where they basically took our system, our 25 kVA system, and compared it to a standard generator running similar loads. So this was a year-long test on it was a guard shack essentially running 24 hours a day, 7 days a week. So the really cool part of this was when they ran this for a full year, we weren't even aware of it, but they shared us the results, and they said the hybrid fuel efficiency resulted in an 83% reduction in fuel burn versus that standard generator on the same type of setup. And that resulted in also a 91% reduction in the diesel generator run hours. So some of these numbers are just crazy. Johnny was sharing some of the fuel reduction he saw in his job, 75, 77% fuel burn reduction. Here we're seeing 83% in reduction, 91% in diesel generator runtime. You're always looking for 5 or 10% efficiency improvements, and we're just leaps and bounds beyond that by adding this hybrid technology into the equation here. The other case is the environmental impact here, carbon reduction over that 1 year, equivalent to about 5 homes or taking 11 cars off the road. In this specific case, they found a $15,000 per year operational savings in fuel and maintenance when you compare it to a standard generator. So when fit for the right job, this hybrid system can really, really reduce a lot of your costs and CO2 emissions and fuel burn.
Thank you, Travis. So now we come to the question and answer session of this webinar. You can email the questions to me at my email address, which is shown on the screen, ssingh@toromont.com, or you can put them in the chat. So we had received some questions earlier on, and the first one is for Travis and Oscar and Johnny, actually all three of them. What are some of the tools available to decide how to proceed with a diesel generator set or to proceed with a hybrid diesel BESS system?
Yeah, I think I can share. From the ANA's standpoint, we've got applications support that can help us size specific jobs and help, through Toromont, reach out to Toromont, and we can work with you guys to make sure that we're sizing appropriately for the project and the application. Obviously, Toromont understands the power systems really well, and we can provide the solutions for that. There are some calculators out there and stuff that I think we can probably get into in the future around how to, what type of fuel savings and that type of improvements and fuel burn and stuff that you want to get into. But yeah, that's something, Johnny, Oscar, myself have a lot of experience with sizing systems and then sizing solutions for the end applications. I don't know if you want to add anything to that, Johnny or Oscar.
Oh, no, I'm all good on my end. Thank you.
Yeah, so what I got from this feedback is it is on a case-by-case basis. One needs to understand what the loads are. And the more the load is fluctuating, going from high to low, there is a greater possibility of using a hybrid system compared to if it was a steady load, then it's more of a generator set application. Am I correct there?
Yeah. If you're running something at a consistent, 80% load on a standard generator, it's probably a really good application as far as efficiency goes. But if there's a lot of variable loads, hybrid can definitely help out in reducing a lot of your operational costs.
Thank you, Travis. Another question is, obviously we have the 70 and 125 kVA units here. If there is a larger application that requires much more larger load, how many units can we parallel? Well, first of all, can we parallel different BESS units together? And what is the limitation on how many BESS units can we parallel?
Yeah, that's a great question. From the eBOS hybrid system we've got here, we really don't have a limitation on how many paralleled systems we can put together. We use a simple droop based frequency load sharing. So if you need a 5 megawatt system, you just pile as many of these systems into that power node as you need. We've got some applications where there's 40, 50, 60 of these paralleled together to build up that larger power node. The really interesting part that Johnny and Oscar would probably appreciate is you can build these systems up into a large power node. So say 100 of these 70 kVA units, you could build a 7 megawatt system. Obviously, there's a lot of real estate concerns there, but you can build a huge power system. And then from the rental side, if you want to split that down into different, you could put that into a bunch of smaller jobs. After that 7 megawatt job is done, you could split this into a lot of smaller jobs. And there's a lot of versatility and flexibility in how you kind of build these systems out, because the parallel scalability is so massive with a hybrid inverter-based system like this.
Thank you, Travis. Johnny, what are some of the certifications that are available on this BESS packages?
I think we covered it a bit, but there's the UL 508, if I'm not mistaken, the UL 9540, and it is a CSA field certification.
Thank you very much, Johnny there. Question for Oscar. If somebody needs a much more larger unit, does Toromont have access to those BESS units?
So I think it's one of the questions in the chat. So right now, as I mentioned, we have a 125 kVA and the 70 kVA, and Travis mentioned about synchronize this unit as much as we can. That is doable. Plus, I think, and Travis, you can confirm if I'm wrong, I think the largest unit that you own is a 400 kVA or around that is the largest one that you have, right? And as you mentioned, you can actually synchro and parallel this unit together and make whatever you want.
Yep. Yeah. I think if you need 25 megawatts, we would just put together 60 of our 400s and say, there's your 25 megawatts. And then when that job's done, it'd be easy, to put this thing on 60, 400 kVA sites, right? So.
Excellent. So we've got some more questions coming from the chat. First one is the presentation. Will it be made available? Yes, a copy of the recording and the presentation will be made available to everyone that has participated in today's webinar. Also, our account managers will be following up with you for any special request or any additional information. Next question is the generator battery only rechargeable via the plug utility connection, or does it charge while the generator is running on diesel?
Yeah, so because this is a hybrid, we are mainly using it by charging it on diesel. So plug in that diesel generator and it'll just charge on that. You can also use a 480 volt grid connection to recharge, but we're really optimizing this thing to work with a diesel generator. So it will recharge using that diesel gen and still discharging, right? A lot of times there's concerns where they say, can you still run the output while you're charging it? In this case, it's designed perfectly for that, right? It's designed to just fire on that diesel generator whenever it needs to charge the battery, but the output is always consistently on and it's running off of the battery itself. So,
thank you. This question for Tormont team, is the generator equipped with a charging alternator?
Yes. Uh-huh.
Yeah, the engine generator set has a charging alternator. Question, how does the transient performance with the step loads compare with that of similar different frequency drop when accepting large step loads on the BESS?
Yeah, I can talk a little bit about that. I've lived that world a bit. A generator, if you run a generator at 2 times its rated load, just starting something, right, that frequency will tend to droop by 5-10% even, depending on how heavy that load is. The BESS is designed for a 1/4 hertz droop across the entire output range. So if you hit this thing with about 100 kVA, I think you would see a 1/4 hertz droop. So it's really a very, very stiff frequency output system when you compare it to a standard gen. Tower cranes really love these things because when they're really moving something quickly, they don't see that droop from the generator. The battery really holds that frequency steady in order to so it really tightens up the control for tower cranes.
Excellent. Thank you very much for that feedback, Travis. Another question, are the units BESS available in 600 volts?
Yeah, we mentioned about that, but it's through a transformer. So as you see on the picture, we have a transformer that goes to 600 volt option.
Thank you. Have you completed an AC coupled system? In this scenario, assuming the generator is in the grid forming mode and the battery PCS in the grid following mode, is there a maximum ratio of power BESS versus generator not to exceed or maintain? Please send me a note and we can take that question. I think it's a little bit more detail. We can take that question on a one-to-one basis. Any other questions?
I think there's one more.
Yep.
Okay.
Type of battery, yeah, it was mentioned it's a LTO, LOT type of battery.
Okay, we still have some time. Any other questions? I'll give it 10 seconds more. While we're doing that, I just want to remind everyone that there is a webinar on September the 25th by Tormont. It's again part of the Let's Talk Energy series. We do about 6 webinars in a year, And the next one is on energy systems integration on September 25th, and it will be again conducted by our Tormont team, headed by Chris DeLeroyers, a very experienced engineer in integrating different energy sources, along with Megan Rooney as the moderator. So in the absence of no more questions, I thank you very much for joining in today, sharing your questions with us. And also, you'll receive a copy of the presentation along with the recording of this, and our account reps will also contact you to see if we can be of any assistance to you. So thank you very much once again from the entire team. Thank you very much, and bye for now.
Thank you.
Thank you.
Bye.
Bye-bye.